Here we are, Math 1. This is our extra in-class practice, which if you didn't get it finished in class, you can use this to help out. And we're just kind of going over some similar questions at 2.4.2 and 2.4.3, proving and recognizing average rate of change. So, these first ones. So, the fuel capacity of a popular hybrid car is 11.9 gallons. The function for this situation is f of x equals negative 0.02 plus x plus 11.9. where x represents miles and f of x represents the amount of fuel remaining. What is the rate of change for this scenario? Well, we find the slope, the growth number, which is with the x, so negative 0.02. So in other words, we lose 0.02 gallons of gas for every mile. Okay. Number 2, same idea, videotaping a basketball tournament. We've got this function, 20x plus 350. X represents the cost of each video. What is the rate of change? Once again, look for the term with the x, so it's 20. So for each video, it would cost $20 more. Okay, number 3, an investment of $750 is invested at a rate of 3.5% compounded monthly. We've got our equation here. Okay, where x represents time in years, what is the rate of change from this interval? So because we're dealing with exponential, our rate of change, we can't just go with the equation. So if we were to graph this, okay, actually should be going up. We go to the interval 2, we find that point, we go to 7, find that point, and then we'd make a straight line to that, and we're finding that rate of change. But to do that, we take 2 for x, and we plug it in to our equation for x, so 12 times 2. Then we do the same equation, and we plug it in 7. And then that'll give us, then we subtract that, that'll give us the vertical change, this one. Then the horizontal change we find by going 7 minus 2, which is 5. So that one's easy to get. Okay, so 12 times 7. So we type those into our calculator and we get our answers. So when we do this first one, we end up with 804.30 because we're dealing with money. Our second one, we get 957.87. So that's the 900, that would be the 800, so we subtract them. 957.87 minus 804.30, and that gives us that vertical difference of 153.57. Then we take the vertical, divide it by the horizontal, and that'll give us our rate of change, which is 30.72. Okay? So 4 is the same exact process. Okay, intervals of 3 to 6. Here's our function, so I put it in for that one, and then get my answer, which is 18.75. Then we do it for the 6. And we get that answer, which is 2.34. So this is going down, right? So I go 2.34 minus 18.75. That gives me negative 16.41, which is my top, because that's a vertical. And then 3 to 6 is 3, so I divide it by 3, and it gives us our rate of change of negative $5.47. Okay? Alright, now looking at number 5, the conversion of inches to centimeters follows a function. Here's several conversions. What is the rate of change for this function? Okay, so looking at the rate of change, let's see if it's constant. Let's see each one. So the difference between 25.4 minus 12.7 gives us 12.7. Okay, so we added 12.7. If we add 12.7 to 25.4, does that give us our next number? 38.1. So we're adding 12.7 each time. And on this side, we're adding 5. So we always go the y value, or f of x value, over just the x value. So 12.7 divided by 5 gives us that rate of change of 2.54. So for every 1 inch, we grow centimeters by 2.54, is essentially what that's saying. Since that's linear, we know it's linear because it has that constant change. Now if we look at 8, this one, we don't have that constant change, do we? But we could multiply by 2 each time, right? So it's exponential. Okay? So the way we do this, it gave us the interval from 3 to 12. So 3 to 12, that grows by adding 9. 18 to 144 grows by adding 126. So 126 divided by 9 gives us an average rate of change of 14. So basically every minute we get 14 more bacteria within this interval. But knowing that it's exponential, it's actually growing by doubling. So if we changed our interval, that would change that number. And with exponentials, that's what you have to deal with. Okay, the table below represents the total cost to ship a package based on the package's weight. So we want two intervals from 0 to 10. So that grows by adding 10. That grows by adding 6.55 minus 5. So 6.55 minus 5.25 gives us a growth of 1.3. So I go 1.3 over 10, which gives me 0.13. So they add 13 cents for every pound, basically, according to that interval. But let's check the other interval. Now we go 10 to 20. So that has a difference of adding 10. Then the difference of adding 6.55 to get 7.85 is 1.3 again. So we could probably tell that this is a linear equation, isn't it? Because it has that constant rate of 0.13 per pound. Okay, the table below represents the worth each year of an initial investment of $6.50 that earns this interest. So doing the same thing, but this time with an exponential growth. And we should notice this linear has a constant growth. They end up being the same thing. This one probably won't. So 0 to 6. So 0 to 6. Our x's grow by 6. Our y's grow by 796.41 minus 650 by 119.41. So 119.41 over 6 gives us 19.90, since it's money. So every year they earn about 19.90 from 0 to 6 years. Okay, now 4 to 8, we're adding 4 here. And then we're adding on our y values, 852.2 minus 744.27 is 107.93. So 107.93 over 4 gives us 26.98. So years 4 to 8, every year we're earning that much. Now if we really wanted to, we could take each of these and divide them by the previous one. And that would give us what we'd multiply by. Basically probably like 1.07 is probably what we're multiplying by. Because it's exponential, we multiply by the same number each time. Alright. Now the second part. So we've got this equation. We need to find these approximate rates of changes here. So we go to 2 for the x. We go up, that's about 0.1. For 7, we go up to 0.4. So the vertical difference of 0.1 to 0.4 is we are adding 0.3. The horizontal difference, we're adding 5. So I go 0.3 over 5 to get my average rate of change, which is about 0.06. Then we do it for 12 and 19. So 12 to 19, it looks to me like they're in the same position here. So we'd go up basically like 0.2, 0.4. So I think we'd go up 0.4. And then our vertical would be 7. So 0.4 divided by 7. Which 0.4 divided by 7 gives us 0.057, which we can round up to 0.06, which would make sense since it's a linear. We should have that constant change. Okay, now we deal with the next one. Okay, let's see if we've got 10 to 25. Okay, they're about in the same position, so we go up 5 each block. So 5, 10, 15. So a vertical change of 15 and a horizontal change of 15. So 15 over 15 would give us 1. Then we do 30 and 65. So 30 goes up to about here. 65 goes up about there. So that would be 35 horizontal. And vertical, that's the change we have to figure out now. Okay, this would probably be about 28, and this 62. So 62 minus 28 would give us about 34. So 34 divided by 35 gives us almost 1. Right, 0.97, which we could round up to none, because since we're just approximating. So I would probably predict for the third interval we would have 1. So the value of the Australian dollar and the US dollar are pretty even. Alright, so got another one with the number of campers each year, 3-day musical festival, same process. 3 to 9, 3 up there, 9 up here. Looks like about 2,000, about probably say 1,400. So the horizontal change from 3 to 9 is 6. That vertical change, 1,400 to 2,000, would be 600. So we'd go 600 over 6, which would be 100. Okay, easy enough, right? Then we do it for 9 to 16. So 9 would be up there about 2,000, 16 would be up here at about 3,000. So vertical change of 1,000 and a horizontal change of 7. So 1,000 over 7 would give us about 142.85, but they're people. So, because campers are people, so probably 143. Alright, now the last 3 questions. Population, small town. So interval of 1 to 6. So 6 goes up to about 4,500. 1 goes up to about 5,500. So vertical change of 1,000, right? Horizontal change of 5. So 1,000 divided by 5, which is about 200. Oh, not 2,000. Getting a little ahead of myself. Then we do 10 and 20. So 10, we're at about 4,000. At 20, we're about 2,750, about halfway in between. So that vertical change would be 4,000 minus 2,750, or about 1,250. Then our horizontal change is 10, so 1,250 divided by 10 would give us 125. So how does the rate of change differ for each interval? By about 75, doesn't it? Okay. All right, there we go for that one.